Hi, this is Mr. Merrill, and I'm going to show you how to do one of these table problems in the quiz bank that a lot of people seem to have trouble with. I think the main issue is many of you are unfamiliar with what's called point-slope form. So there's more than one way to write a linear relationship. Almost everyone learns slope-intercept, which is the y equals mx plus b, but this is just as valid of a way to write a linear relationship, and we'll need to use it to solve this equation. Okay, so that's probably a starting point. If you've never seen that before, you might want to Google that separately before you watch the rest of the video. So to try to answer this problem, we're essentially given this condition. We want to, at some point, come up with an algebraic model for this relationship that's shown in the data. And the first step of getting an algebraic model is to find the slope. So we can use any of these 2 points here. I just chose the first two, but we could have used any two in combination with our slope formula. So we're going to plug those into our slope formula, simplify, and use the decimal answer as by convention. You can check yourself and hopefully you get the same thing that I do. So once you have the slope, we can use this point-slope form. It just requires us to have the slope and a point. It could be any point. I just picked this one. It doesn't matter. You could have picked any of the other 2 points. So with that choice of a point that is in the relationship and the calculated slope, we can use the point-slope form. So the tricky part, I think, for a lot of people is going from something like this to something like this. So let's talk about where those things came from. First of all, when you're given a table, it's by convention that this is the IV and this is the DV. So if we were to graph this, on this axis we would have force, because this is the dependent variable axis, and on this axis we'd have time, because that's the independent variable axis. So when we're talking about a coordinate, it would go time, comma, force. But remember, this point-slope form is talking about a generic x, comma, y. So when you see this y here, what it really means, in terms of a more general thing, is that this should be the symbol that represents what is going on the vertical or y-axis. Really, we want to say vertical. So that's why the F is there. Then this is just the y-coordinate or the vertical coordinate in your point that you chose. So that's 6 newtons. The slope, m, is what we calculated on the previous slide. X is the symbol used to represent that horizontal x-axis. So we're going to use the symbol t. And then finally the horizontal coordinate, or the first coordinate in your coordinate pair that you chose. So plugging that all in, we get this relationship, but it can be simplified quite a bit. The first thing I'm going to do is take this slope and distribute it to inside the parentheses. So it's going to change this negative 20 seconds to a positive 10 newtons. Why did the unit change? Because newton over a second times a second. This is from the slope and this is from the value there. Will give you a unit of a newton. That's why the unit changed. And then I'm just going to add 6 newtons to both sides to get something that we're familiar with. This is kind of the old slope-intercept form of our algebraic model, and this is really what you need to get to answer any of these problems. Okay, so take your algebraic model, and then we just need to satisfy this equation. It says what is the value of the force when t, or time, equals 0 seconds. So all I did was replace the time variable with the specific condition of time equaling 0 seconds. So place it in there. That's going to make this first term 0, so the force is just 16 newtons, and my answer is right there.